Hey, you love parallelograms so much you want to learn more about them? Me too. All right, so you learned about parallelograms, you learned about rhombuses in particular. We're going to get even more specific. We're going to look at rectangles and squares. So first off, we got our properties to the right. For rectangles, we've got that they're parallelograms, which is all those properties from the first one, from the first video you watched. Here we got a new one. There we have 4 right angles as they're marked right here. You can see them, 1, 2, 3, and 4. And the last one says the diagonals are congruent, which means this line right here is congruent to that one. Let's see how these might work. Our first question says, if BD is 10, what is AC? Well, BD is this diagonal right here, right? I'm doing in green. So the length of that is 10. So if that's 10, what is the length of AC, which is this diagonal? Oh, you guessed it, it's 10, right? Property 3 says our diagonals are congruent. So property 3 says that BD, wrote it backwards, sorry. That BD is equal to AC. Pretty simple, we know BD is 10, AC equals 10. That's the first one. Let's look at number 2. Oh, sorry about the screen. So number 2 says, we have ABCD is a rectangle. If angle A is 3x plus 24, what is x? Well, so angle A is this whole piece, right? But we know from our properties that we have 4 right angles, right? So that means by this second property, we can say that angle A is equal to 90 degrees. Because we know we have 4 right angles, right? But they told us what angle A is. They said angle A is 3x plus 24. So we can just set that equal to 90 degrees. And then solve for x, right? So we're going to subtract 24 from each side. We end up with 3x equals 66. Divide both sides by 3. And we get x equals 22. So right there, you're just simply using those properties. Really, those are the only things, is just understanding that the diagonals are equal and that you have 4 right angles, and then going back to all those parallelogram properties. So that's rectangles. Let's see what's going on with squares. Oh, there's the screen again. Sorry about that. So here we are with our squares. And with squares, we've got 3 major properties. Again, that they have all the properties of parallelograms. Also, like rectangles, they have 4 right angles. The difference here is that they also have the properties of a rhombus, so it might be good to flip back as I reference some of these properties so you can refresh your memory. So number 1 says the following is a square, find the value of x. Well, we know that all 4 sides of a square are equal. Right? So that means we know 3x plus 17 is equal to 18x minus 13. And we also remember that from our rhombus properties, right? So that means we just set these sides equal to each other. So 3x plus 17 equals 18x minus 13. So subtract 3x on both sides, and we get 17 equals 15x minus 13. So I'm going to go ahead and try to get the x by itself. When you add by 13 on both sides, you're going to get 30 equals 15x. Divide by 15, and you get x equals 2. So now you can kind of see why, a square is the way it is, because it dates back to our rhombus properties. So that's one way you can see a problem. The second way is right here. It says figure ABCD is a square. What is the measure of angle ODC? Let's draw that. Here's O to D to C. So it's this angle right here. And this is where you're going to use a combination of a new property and an old one. Now, what can you tell me about angles A, B, C, and D? If you're unsure, look at property 2. It says we've got 4 right angles, right? So property 2 tells us, I'm going to draw them in blue, that all of these are right angles. We know that. Okay, so based on property 2, I can say that angle D equals 90 degrees. But angle D is this whole thing. I only want this small piece, that angle ODC. This is where we're going to go back to a rhombus property. If you remember, rhombuses, the diagonals bisect the angles. We just did this, remember? So that means our diagonal BD, which I'm going to trace over in black, is cutting angle D in half. So that means angle ODC equals half of the whole angle of D. Well, what happens when you do 90 divided by 2? You get 45 degrees. Simple as pie. So that's another example of sometimes you're going to have to combo the properties. But I'm pretty confident that you all can do this. So try some problems on your own. It's going to be a mix of both rectangles and squares. Use these examples to guide you, and you always have Siegel and myself to give you help. Good luck.